Everyone, welcome back. Let's write some more Leetcode today. Today we are solving 2-sum. I will go over 2 ways to solve this problem, but I will only write out the code for the optimal solution. If you are only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an array of integers nums and an integer target, and we want to return the indexes of the two numbers so that they can add up to target. And we may assume that each input will have exactly one solution only, and we can return the answer of the indexes in any order. So for this example where the target is 9, 2 plus 7 equals 9, so we return indexes 0 and 1. In this example where the target is 6, 2 plus 4 equals 6, so we return indexes 1 and 2. And in this example where the target also equals to 6, 3 plus 3 equals to 6, so we return indexes 0 and 1. So, how can we solve this problem? One way that we can solve this problem is that we can loop through all the elements in the array. And for each element, we can try adding all elements to the right of it and see if it can equal the target. And we will continue that until we find a match. So if we can go through this example, now 7, we try adding to 2 equals 9, does not equal target. 7 plus 11 equals 18, does not equal target. 7 plus 15 equals 22, it still doesn't equal target. So now we try this one. 2 plus 11 equals 13, it does not equal target. 2 plus 15 equals 17, so it does not equal target. So now we try 11. 11 plus 15 equals 26, and that equals a target. So then we can return the indexes, which would be index 2 and 3. And the time complexity of this would be O of n squared, because we have to loop through each element in the array, and then we have to compare with every other element to the right of it. So that may take up n squared time, where n is the length of the array. And the space complexity of this would be constant O of 1, because we are not using any extra space. So there's actually a more efficient way to solve this problem, and we can look at that one right now. So to make this problem more efficient, we can create a hash map. And the intuition behind it is that, so for example, we have number 2. We know that the number we need is 24, and we can find that number by subtracting the target to the number that we are on. So target minus 2 is equal to 24, so we know 24 is what we need. If it's 7, the number we need would be 19, because target minus 7 is 19. So what we can do is that we can iterate through the array, and in every iteration, we can add the value and the index to the hash map. And whenever we get to a number and the difference is in the hash map, then we know that we have a solution and we can return the indexes of these two numbers. So let's just go over this example. So we get to 2, the difference of 2 is 24. And 24 is not in the hash map, so we will continue the problem. We will add a 2 and index of 0. Now we get to 7. 19 is not in the hash map, so we continue the problem. We will add 7 and index 1. Now we are at number 11. 15 is not in the hash map yet, so we continue the problem. We add 11 and index 2. Now we get to 15. The difference 11 is in the hash map, so we could return the index of 15 and the value of 11, which is 2. And the solution of this problem could be 3 and 2 or 2 and 3, since we can return the answer in any order. So the time complexity of this would be O of n, since we have to iterate through the array that we are given. And the space complexity would be also O of n, because we have to create a hash map that could be the length of the array that we are given. So now let's get to the coding part. So first we can create a hash map, and we'll call it previous. The keys can be the values of nums, and the values will be the indexes of nums. So we're going to loop through nums for index value in enumerate nums. So first, we're going to calculate the difference by subtracting the value from target. And if that difference is in the hash map, then we can just return the two indexes. So we will return previous with the key difference, and that will give us the index, and index itself, which is the number that we are currently on. Otherwise, then we will add the value and index to the hash map. So previous of value is equal to index. Okay, let's see if it works. Perfect. Okay, hope this was helpful, and I thank you all for watching. If you guys have any other questions, feel free to leave it down in the comment section. And I hope to see you all again soon. Thank you.